Question of the Week from the Naked Scientists.
Hello and welcome to Question of the Week. I'm James Titko. Today's question comes in from listener Dave.
Hello, Naked Scientists. This is Dave from Hobart, Tasmania. I was wondering if there is any other way to produce electricity from nuclear fission apart from generating steam to turn a generator. Thank you.
Thanks, Dave. I suspect this might be a follow-up from our recent programme on nuclear energy. As you indicate, the way a traditional nuclear power plant works is by splitting apart heavier atoms from the periodic table, usually uranium, and using the heat energy this gives off to boil water, using the steam that's been produced to spin a turbine, eventually converting that kinetic energy into electrical energy. But is this the only way to get energy out of a nuclear reaction? Well, as it happens, there are other methods, and we've happened to cover one in this week's news show. The carbon-14 diamond battery, designed by Professor Tom Scott from the University of Bristol and his colleagues, harnesses energy directly from the decay of radioactive carbon-14 atoms, as he was telling Chris earlier. These methods are harnessing the energy from the decay of radioactive atoms, not from a fission reaction, like you were asking about, Dave. So are there alternative methods of generating energy from nuclear fission specifically? Well, yes, in theory. One way is by directly using the kinetic energy from fission products. Let me explain. In a nuclear reactor, the fission process splits uranium atoms into two lighter fragments moving at high speed and thus possessing a lot of kinetic energy. The fragments are also positively charged because they've been stripped of their electrons. If the nuclear fuel is made really thin, on the order of microns, these fission fragments could escape and interact with an external system, such as an electric field. Attracted to negatively charged electrons, they could transfer their kinetic energy to said electrons crowded on the electrodes, creating the electric field, producing a current. Now, this is a very exotic application with numerous technical challenges to be overcome, the need for ultra-thin and durable nuclear fuel, for example, but it's fascinating nevertheless, and an active area of research along with other experimental methods that are worth keeping an eye on. I hope that's answered your question, Dave. Thanks so much for sending it in. Next time, we'll be answering this question.
Hello, it's Damien from Hathersage in the Peak District in the UK. My question is, if the continents were once all joined up as a supercontinent, what was on the other side of the Earth? Was it all just water?
Thanks, Damien. Question of the week is going to be taking a little break now over Christmas, so while it may seem like half the world away, we're looking forward to answering that one when we return. Remember to have your say on this and all of our other questions on the forum. Log on to nakedscientists.com/forum and be sure to drop us a line if you have a question of your own. It's chris@thenakedscientists.com. Until next time, from me, James Titko, thanks for listening and goodbye.
Question of the Week is part of the Naked Scientists podcast. Look us up online at nakedscientists.com.